Yeah, hello, Hub Berlin. I'm very excited to be here today and to share my story with you, how 3D software and 3D printing helped me winning 2 medals at the Paralympic Games. So at the beginning, I would like shortly to introduce myself. I'm Denise Schindler. I'm a professional cyclist since 6 years now. So I'm getting slowly old. And I've been already twice a world champion. I am 3 times medalist at the Paralympic Games. And yeah, I'm still hungry for more. So my next goal are the Paralympic Games in Tokyo 2020. So watch out if there are some medals more coming. What is special about me? When I was 2 years old, I hit the train and I won. But somehow I lost my leg on this way. So since then, I have to walk through life on a prosthesis. I am a girl, and a girl always needs different kind of shoes, so I need different kind of prosthesis. So whatever I want to do, like right now I have a regular walking prosthesis, which I get covered by the insurance, but I also have different kind of prosthesis, like a cycling prosthesis, or when I go for swimming, I have a special prosthesis for that as well. On the picture, you can see my prosthesis expert and a couple of prostheses I have. Obviously, my problem is that my shoes, I can't buy them at Zalando. So if I would go on the website, obviously I can't order them there. So what I have to do is to go to my orthopedic technician, ask him to do me shoes which are 100% handmade. They are not made in China, so I'm asking to do a new leg, and he's doing that for me. In the picture, you can see my prosthesis expert. He's almost 60 years old now, and he's doing my prosthesis since over 25 years. So he's got a huge knowledge on how he's doing that. And I show you a different picture. It's a very hands-on, traditional way how it's manufactured at the moment. So it all starts with a plaster cast. So the first thing he's doing with me, he's getting a plaster cast of my limb, and then he started working with it. So then we get a test socket, and with the test socket, I'm able to test if the prosthesis and the socket is fitting, and I give him my feedback, and he's doing some couple of changes, which takes like 2 to 3 weeks. And after that, I get the regular prosthesis at the very end, which is made out of carbon. So you can hear that's a bit an old-fashioned way of producing prosthesis, and we wanted to change that. The future. It's been 3 years ago already now that I started talking with Autodesk, and we had this vision and the idea of making prosthesis in a different and a new way. So we started very easy and very simple. So what we did at the very beginning was just to scan my limb. And this is Mickey Wakefield laying down on the ground trying to scan my leg, the rest of my leg. And with that, it may sound funny and weird, but it was the first time that we got a 3D version of my limb and that I became a 3D patient. So now I was available for my orthopedic technician anytime, anywhere, because we had a software and I become a 3D patient. In the software, we could do a precise modulation. In the past, always the problem was that the software was not able to combine the organic forms with the needs of mechanical engineering, especially if you have the modulation process for prosthesis. You don't want to have sharp edges, because sharp edges cause pressure points. And that's not working for us. If we get pressure points, that's a lot of pain, and we can't walk in a prosthesis anymore. So we really need a software which is able to combine the organic forms. The precise modulation on the 3D scan is the basement for a good fitting socket. You have to know that if we have the scan of my limb, and we have a 100% negative of my limb, that's not a perfect fitting socket. Just with the modulation of my prosthesis expert, who is expressing what kind of areas of my limb is able to hold my body weight, and which are like bony parts of my limb, and I should reduce the pressure of that areas. So with the modulation, we become a socket which is able where I'm able to walk in the prosthesis without having pain and without having pressure points. What is also very new and a breakthrough was that we've been able now to work together in a cloud-based software. And we had a lot of people involved in the project. And you see the crazy guys on the left, on the right. On the left, that's Paul Sohoy from Autodesk, Autodesk evangelist. On the very right, that's me, a crazy athlete who travels all around the world, who's always in training camps like South Africa and Spain, Switzerland. I always pick the countries who are very nice and where is the sun. And I'm traveling for all my competitions all over the world. So I'm in Japan, I'm in the US, I'm in Europe, so wherever a race is or where championships are. So I'm never available, most of the time locally. So for me, it was very important in the new way of producing prostheses that I can give feedback via email, via cloud, or via phone, and not having the necessary need to be there locally to get the procedure on. And in the middle, you see the musketeers, I would call them. This is my prosthesis expert with his son, who have their workshop somewhere in Bavaria on the landscape, like 2 hours from Munich. You wouldn't know that town, it's a very small one. And other people from Autodesk who were involved and based in Munich. Moreover, we had different experts who were involved in the project. For example, we had FES institution here in Berlin who are experts in aerodynamic. So because I'm a Paralympic athlete cycling, you know, all the fancy helmets and positions we are taking on the bike. Also, my leg needed to be aerodynamic. So we involved these experts in the project, invited them in the cloud, and they've been working on the aerodynamic stuff. On the other hand, we had experts which took a look at the power output and the transmission, and that we've been able to get a very stiff prosthetic. So we have now, with the cloud, a chance to have a transfer know-how, which is normally not possible in this way. Because if we go back to the traditional way, how we are making a prosthetic, all these experts would have need to be in Bavaria at the workshop of my prosthesis expert to work on that project. And that's, now in this time, it's not possible anymore. So with the cloud-based software, we've been able to work with really a lot of experts. And what else was possible, that we had different drafts and could go back and forward all the time. So you have to imagine, Paul Sohoy sent me the first draft of the prosthesis. He thought he's done with work. And I tested the prosthesis. We had a very first draft. We printed it and I tested it. And he thought, yeah, that's done, awesome. Denise got a prosthesis. I tested him, gave him feedback like, no, I want something different. So it was very challenging, Paul and the Autodesk team, to give me really a perfect fitting prosthesis, which is really working for me at the Paralympic Games. So everything has to be 110%. So we've been able really to go back and forward and to have different drafts. I think the first, until we printed the first leg, was like 60 drafts we had, until we were able to print that one. So 3D printing, after 60 drafts, I told you, we've been able to print it, and it looked like this. It's a time lapse, super easy. So why did we take 1.5 years to do that? Well, it was not that easy as it looks like now. But yeah, basically it is how it is. So when you are ready with the drafts, you're just able to send the file to a 3D printer and he's doing the job. So there's no need anymore for my orthopedic expert to produce the prosthesis on his own, like we do in a traditional manufacturing. So he has more time now on the patient itself, on the precise modulation, than on the time having produced the prosthetic. This is how it looks in the end. A fancy leg, this is aerodynamic. And you may wonder now why, if you look at the leg and the length, there is no foot at the end anymore. I am cycling with it, so for me it's just a sport tool that I use. And so there's no need for me anymore. At the very end we have a cleat, and I just click right into the pedal and start cycling with it. So it's not made for walking. I can go for a cup of coffee in between riding in Spain. After 2 or 3 hours, I go for a cup of coffee, but it looks more like Captain Hook. But, it's cycling. On the other hand, we've been able to use different kind of shapes and new shapes. My prostheses before have been very technically. Here we have a new design, which is like very thin and very aerodynamic. Last year, we had the opportunity to introduce this project to these two guys. Obviously, Angela Merkel and Barack Obama. I was very happy and pleased that it was right in time that it was still Barack Obama. Imagine a German woman disabled talking to Donald Trump about a prosthesis. Would have been very funny. It was a very nice conversation with both of them. We've been highlighting the benefits, and was really impressing to me that Barack Obama, as a sportsman, was also recognizing the benefits. That it's not only regarding me as a Paralympic athlete who's benefiting from the new kind of the way we can produce prostheses now, it's also the wider perspective that we can have more benefits for the average amputated person. So what are the benefits? Benefits are that we can reduce the production time on the one hand, that we can ease the production for the orthopedic technician and expert to have more time on the patient. That means as well that we can reduce the costs for the prosthesis. And that also, in my mind, is a chance that an average amputated person can afford a prosthesis, a sports prosthesis on his own, because they are not covered by insurance. Just a normal walking leg is covered by the insurance. Also, like with 3D printing, we have the chance to print new materials and to combine new kind of materials. And my vision is that we can reduce pressure marks with that. For example, in the socket, we have different kind of pressure points. We need areas where we need a big stiffness outside, but we need soft spots inside because these are areas where are very bony and we can really have pressure on that points. So being able to do 3D printing in different kind of thickness and materials, we can adjust it and avoid pressure marks in the future much better than we are able now. Also, for me as a Paralympic athlete, I can, get my sports tool well equipped, having a look at the aerodynamic, having a look at power transmission. But this is more a sports side. This is not the wider perspective for an average amputated person. In the very end, I got 2 medals at the Paralympic Games in Rio, which is awesome. And I've been able, thank you. This is a nice picture after the time trial. I won a silver medal, which I never expected. And to give you some insights, just a change of the prosthesis from the version I had before, manufacturing in the normal way, in the traditional way, to 3D printed version from Autodesk. It saved me 2 seconds at 3 kilometers time trial on the track. We tested it. So that's a lot. Yeah? So imagine, this was a time trial 20 kilometers. There's some seconds more. So it's really a benefit that I had for the games, and it helped me a lot on getting and winning medals. But I would like to open up your mind on a wider perspective as well. It's not just about medals at the Paralympic Games. For us, prostheses are like shoes. So if you go running for a marathon, you wouldn't take your fancy shoes right now. You would take a running shoe and to go with that running. If you take your business shoe for that, what happens? It causes you pain and it's not working at the very end. And the same for us. If we have different kind of legs for the special needs and interests we have, we can really pursue what we want to do. Like I can pursue cycling and a new kind of level I would have never been able with a normal walking leg. I finished the Tour Transalp, for example, this year as the first ever amputated woman who ever did that. So that would not be possible without having a special leg. And what is a disability about? Disability is just about that you have limitations, so you're not able to do what you have been able to do before. If I have a tool now, what is enabling me to do that again, I'm not disabled anymore. You know, disabling is just in your head because I can't do things anymore. So if you have the chance with a new kind of process to open up this world again to the average amputated, he's able to afford the prosthesis again, and he's now able to run again, or to cycle again, or to go climbing again. You open up the world he had before. And especially one, where's my heart in, I would like to open up this world for kids who are amputated. I was amputated very, very early. And to me, sports as a child was never really a big joy because I had no special prosthesis. And for me, doing sports was always combined with pain. I would like to change that, and I would be more than happy if that would change in the future. And we could together, and I would really like to invite you to work with me on a project more and more, that we can open up this world and to enable kids to smile and run like that. And yeah, to do and to create a better world. Thank you for your attention.
Denise, thank you so much for sharing that with us, and what a great analogy that prosthetics are like our shoes. I know I certainly would not want to have to run a marathon.
Shoes.
These are fancy shoes. They're for standing. They're not for walking or running. We have time for just a couple of questions. If you have a question for Denise, you can throw your hand up, and I will try and find your hand.
You don't have to cycle with me. You can ask.
Everyone's feeling shy. We're getting towards lunchtime. Yeah. I'll ask you a question. Tell me a little bit about exactly what you're doing at Autodesk.
So my part is like to challenge them all the time again.
Challenge them?
Yeah.
It seems like you'd be good at that.
Yeah. So basically, I'm the person who's like testing it outside. You know, the one hand is like what you're doing in the software and what are the drafts about. But the other hand is like, is it really working in real life? And that's what I'm doing and giving the feedback. And we are really, together with my orthopedic expert, working on the process that the software is getting more available for the orthopedic expert. Because you have to know, they are not 3D evangelists.
Yeah.
So they are not used to a laptop and a software. They're used to making everything handmade.
It's a craftsman type job.
Yeah. So it's really the challenge to get the orthopedic experts on the notebook and to have the transfer from the handmade way to the digitalization.
And how is that working? Are they open to the idea?
Yeah, well, it's always challenging, both sides.
That's a very diplomatic answer. That's the kind of answer you'd expect for an Olympian.
Yeah,
Denise, thank you so much. If you have a question for Denise, she is going to be available right at Meet the Speaker. So you just walk straight out this door and turn right. Give her about 5 minutes so we can de-mic her, and then you can meet Denise and ask her any questions you were perhaps too shy to ask on the stage. Let's get a big round of applause. Oh. All right, you ask your question at Meet the Speaker, please, because we are now running out of time. I'm sorry.
Oh, yeah, he's coming.
All right, come on. Yeah.
All right, hello. At the Olympics in Peking, there was a big discussion concerning the swimsuits, which gave a big impact on the final capabilities of the swimmers.
Yeah.
Do you think that some restrictions will be required in the near future on prosthesis as well?
Definitely, because we had that big discussion for the sprinters in running because of the blades, different blades they use. And we have for cycling, you have a UCI improvement that you have to do. So means before you start racing, and the tools that you use for the race are approved by the UCI before. Just imagine, I could use a power or echo or something that's giving me an extra advantage. So for sure, that has to be approved, that I'm not cheating, that I'm just optimizing, but I'm not cheating at the end. So yeah, there is a regulation on that, for sure.
Thank you.
Optimizing, but not cheating. A good note to go out on. Denise will be available if you have another question. Let's get another big round of applause for Denise. Thank you.